Hello, everyone. I'm Tim Santos, Director of Product Cloud Solutions in Graphcore. And I'm here to talk about accelerating NLP pipelines with hardware and software synergies. So, summary of what I'll go through today would be I'll be talking about our hardware, then the software ecosystem, and then have a brief demo of what it would look like running a Hugging Face model in the cloud on IPUs. So, who are we? As Graphcore, it's our mission to deliver the world's best processors to enable the next breakthrough in machine intelligence. So, both processor and software on top of it. And why do we even bother creating new hardware? So, this is one of the essays written by Google a few years back, which basically just says, to a hammer, everything looks like a nail. So, the solutions that we're seeing right now are the best solutions that both the hardware and the software has to offer. So they're not necessarily the best solution, but at this current time. So in order to have those breakthrough, the next wave of innovation, like what I mentioned earlier, we create new hardware, we create new tools, so that it's not just the same old type of architecture, the same old model that's just getting larger and larger in size, but you are exploring we're enabling the innovators to explore new architectures. That's pretty much it. And how we do that is, as I've mentioned, so we have designed our own IPU processors, our intelligence processing unit, which is designed from ground up for AI, build the software on top of it, and also build systems that allows you to scale to larger models. And that is why we have created the intelligence processing unit, the IPU. Um, we call it the Bow IPU, which is the world's first wafer-on-wafer processor, um, which basically stacks multiple silicon wafers one on top of each other. This allows for better power delivery, hence faster clock cycles, and then the way we have also designed it, so it's a completely new architecture designed specifically for AI workloads. I'll go on later on, but here you can see it's massively parallel with 1472 independent processor cores with 8,832 different programs running at the same time. And you have like a very big in processor memory. That means it has instant access to large chunk of memory. And why do you need that? So basically, you have different processors working on different workloads. They're optimal for like CPU, optimal for scalar calculation, GPUs for vector, matrix multiplication. And the way we have designed our processor is to be able to handle sparse matrix calculations, graph neural networks, and so on and so forth. So these are like the new types of models that are suitable for AI. And this is a closer look at what it looks like from a processor or compute perspective, and the memory, wherein the processor is like the the pink boxes here, and you can see that the memory is disaggregated. They're distributed and closely coupled with each processor core. So each one of those tiles being able to run its own independent process on a uh, smaller block of memory of data. So so it's ultra fast memory access because it's in processor, and you have massive parallelism. So the architecture is um, multiple instruction, multiple data, and executed in a bulk synchronous process. So it's a really different paradigm that allows you massive parallelism. And so from my title, accelerating NLP pipelines. So one way, one view is to accelerate your pipeline through the hardware, right? So you have faster access, higher memory, higher bandwidth. higher clock cycles and all that. So that's from the hardware perspective. On software perspective, we want to be able to we have made the software ecosystem. We have created a mature. You need a mature software ecosystem, and what this means from our perspective is that, like, from the low level, from the foundational side of things, we have made things bespoke for the hardware, um, like the graph compiler, up to the low level programming language, but everything on top um, is your standard software development tools, frameworks that developers are familiar with. So your PyTorch, TensorFlow, integration to various system software such as Kubernetes, Slurm, Docker. Um, so this this is what our software ecosystem looks like. So it's not enough to just have these like enabling software, but also you want to have on the top right your advanced tooling and visualization tool. Just because we have a different paradigm, you want to be able to see what's going on under the hood, and we can go through that a little bit later. So another way to accelerate the development life cycle um, is by enabling by making available like wide coverage of your model portfolio. So we have our model garden, which currently, as it stands, has like 50 or more, and counting models that are ready to run out of the box. They're optimized to work on the IPUs. That as I was saying earlier, like, it's a unique architecture. So you need the software on top to really utilize that power, and also you want to have like examples, and for those who would have models readily available in their pipelines, in their workflow, you want to have interoperability and being able to swap in models running on IPUs, so as not to disrupt like a migration of your NLP pipelines, or let's say develop like integrating uh, the IPU or a new accelerator in your incumbent pipeline and software ecosystem. So we have vast. That's what we have been working on, making a broad coverage of your state of the art models. That's optimized towards IPUs. And because of that, we are able to, with a combination of your hardware and software synergy, we're able to get like an advantage, like performance advantage for running here as an example, BERT model in IPUs. So here is an example of one pipeline wherein at pre-training we're getting 2.8x performance advantage against GPUs, fine tuning at 2.5x, and inference at twice 2x the performance advantage. And this is what it would look like so performance per dollar advantage. So cost is always going to be um, important when you have your deployment production level models and NLP pipelines. And we do participate. We submit our models in we participate in the MLPerf. So these are numbers that we have for our MLPerf submissions. So as you can see, these are basically just the numbers that we have shown. I have shown earlier about like free training, fine tuning, and inference, 2.1 to 2.8x performance per dollar. So similarly, this is your inference advantage. And what we have, we had a use case wherein um, um, a startup called Lab Genius with their work on drug discovery in healthcare. So wherein they just took out of the box BERT large model and trained their own data set on this out of the box model, which has gained them twice the time, half the time it takes on their comparable GPU. So from 1 month to 2 weeks. So this is quite a significant speed up from a time to value perspective. So if you're doing experiments and you need to run a couple hundred experiments, so that saves you so much time, especially in the drug discovery space, wherein you know you 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 wanna sort of find the subset of candidates of drugs before, there's a very long um, cycle or the path towards like clinical trial. Even clinical trial takes quite a long time. So as much um, speed up in the process that you can get, the better that you are with getting your drugs in trial or even in tested, approved, and all that. So um, so the other benefits, because of the new type of architecture and software on top, you're able to also explore different types of model architecture, different training schemes. So here is an example of our um, a paper that our research team has produced on group transformer, which basically takes your transformer model but is able to utilize a massively parallel compute of IPUs and reduce the number of parameters by uh, by half the number of parameters of your standard transformer model, and therefore also allows you to train it twice as fast. So packing as well is another example of this model innovation that has been made possible because of the unique architecture of IPUs. So here are numbers wherein your your standard BERT large model was trained half half the time with group BERT and at the same time BERT large with a lamb optimizer has training also at a slightly like less than 2x faster, 1.6x. So but then these there's a reduction in the number of parameters. So those are like so we have I've shown some of like how you would accelerate the runtime basically, right? So but I think accelerating pipelines, accelerating the whole ML AI development lifecycle is not just about the time to train, the latency, but also the time involving when you say you got your problem statement, came up with your hypotheses, or even by the time from the time you took code from the repo and started running things. So integration to third-party tools is basically one way that we view would accelerate the ML NLP development lifecycle, and Hugging Face being one of the more popular libraries for NLP is a key strategic partner and an integration piece that we have really worked towards. So we believe that like ease of use is very important. So we have integrated with Hugging Face, and enabling what we call the optimum Graphcore library. And what this is basically a library that lets you run model check take model checkpoints from Hugging Face Model Hub and run it in the IPU and optimize in the IPU ecosystem, in the IPU hardware. So it's pretty much very similar to the Hugging Face Transformer class. As you can see here on the left, you have your trainer, and on the right you have an IPU trainer. Um, yeah, so accelerating by making libraries available that are familiar to developers, ML engineers, and data scientists. So as I mentioned, so what it does is lets you access a lot of pre-trained weights within the Hugging Face Hub. It lets you integrate with the Hugging Face datasets. That lets you sort of mix and match different datasets in the Hugging Face Hub. And also access to people, to the community who have familiarity with the Hugging Face ecosystem and how to develop transformer models. So again, similar to the model garden strategy that we have. So we make optimized models available in the model hub, wherein all the IPU configurations are available there. But of course, nothing stopping the when you have like a very specific workload that you wanna run your NLP workloads on, then it has a very similar interface to the transformer libraries. So you got out of the box models, but at the same time lets you develop your own models easily. So those are like, as I mentioned earlier, as part of a mature software ecosystem, it's not just the ease of getting started, ease of using the frameworks, the programming language, but you want to be able to accelerate your workloads, and having a different architecture requires understanding of what goes under the hood. So we one of our core development tool, like one of our important development tools is the PopVision graph analyzer, which lets you see what is happening in the IPUs in the processor. So I've mentioned earlier, like there's like it runs, it executes in a bulk synchronous process, wherein each tile, each core is running on a specific chunk of data, and in order to sort of optimize these kind of workloads, so the bulk synchronous process involves like a processing steps and waiting and syncing. So waiting for the other cores to finish their process, and then they're syncing, exchanging data across tiles, and then this cycle continues. So as you can see here, everybody's let's say here in the IPU 0, all of these are like individual cores, individual tiles running a compute process, and then you will see that some of them would finish earlier, so they're waiting for others to finish, and then there's going to be like an exchange, data exchange step processes. So, and then process, exchange, wait, and so on and so forth. So yeah, so you need these tools to be able to optimize your workload. And so those are some of the things from the development and model development side. And aside from ease of use, we think that ease of access is also important. It's at the it's one of the most important sort of principle that we have in enabling ML engineers, data scientists, and AI practitioners to adopt IPUs. So ease of access in the cloud. You want to have like minimal setup time, so we have integrated with partners such as Paperspace. So this is a cloud MLOps platform which lets you which we have development environments and runtimes readily available through Paperspace, and we have also made IPs available to let's say Gcore, which is another cloud partner, which lets you run production environments in the IPUs. So those are like a summary of like the quick walkthrough of what the principles of our Graphcore's principles are to accelerate NLP pipelines in IPUs and the cloud. So easy access to powerful, secure, and efficient AI processing. So there's the hardware side of things. There's the software ecosystem, supporting every stage of the AI development journey, familiar developer frameworks and deployment environments, availability of advanced analysis and development tools once you have already, in order to really extract every compute power that you can to really optimize your pipeline and making it accessible, ease of access, affordable, and scalable. Maybe just to give like a quick demo on how it would look like running NLP models in IPUs. I'll just give like a quick demo. You can go to huggingface.co/Graphcore, or here in this case, let's have a try in Paperspace. Okay, let's see. So if you go to paperspace.com/Graphcore, that should bring you to a sign up page. This gives you access to free IPUs for 6 hours on an IPU Pod 16. So a Pod 16 is a system with 16 of the IPUs, and that's a pretty powerful machine. So once you've signed up and signed in, if you click start building, it should lead you to your workspace, your dashboard, and creating your own launching your own runtime is quite straightforward. We have made the SDKs, the environments readily available. So we have here Hugging Face optimum runtime if you want to run on other frameworks, PyTorch, TensorFlow, and what we have done is pre-curate all the setup so that you won't have to, but it also allows you to change things up, preload a certain repo, your own GitHub repo. This loads our standard SDK, the official SDK from a Docker Hub. So yeah, and you basically just start this runtime. There's also another way to launch runtimes. So in our Hugging Face page, you'll be able to see this run on gradient button. So in one click of a button, you'll be able to do exactly the same thing that I did earlier, which lets you start a machine, and in this case, it will load the same IPU pod. As you can see in the logs, it just spins up Jupyter server at the back end, and yeah, and this loads your notebooks. As you can see, in a few seconds, it's able to spin up some of the like the IPU VM. This is an example of BERT fine tuning Jupyter notebook, which we made available for you. Just stepping through them. Yeah, you could try it on your own, but basically, what this notebook will show is like how it looks like on the IPU. So let's see. Yeah. So this notebook will contain like fine tuning. It shows you that it uses a model from the Hugging Face model hub, a pre-trained checkpoint, and loads it up into your standard transformer class. And these type of execution with a unique sort of architecture of IPUs is being abstracted from your view, because we have made this available through the IPU configurations. These are basically like how how a model is parallelized across different devices, how data is divided into mini batches. So if you have like a pod with 4 IPU devices, so one mini batch goes through one IPU device at this chunk of time, and then it goes through the other parts of the pipeline, and then another mini batch is prefetched and run on IPU device 0, and then so on and so forth. And it's shown here like how a model is divided, parallelized across multiple devices. So if you have 24 transformer layers, it's split up into here it's 3777 in each of the IPU devices. So yeah, so this is another example that I wanted to show you was one of the PopVision graph analyzers. So this is what this tool looks like. As you can see, this is showing every point there shows the type of execution that's running in a specific tile. So in this tile, in this IPU device 1, I've mentioned earlier, there's like 1,472 tiles. So you can look at what is actually happening in each of these tiles. So here it's compute. If I zoom in a little bit there, you'll be able to see that there's a sync, there's a wait step, and then sync. Then as you can see in you could also inspect the other IPUs. So this lets you tune and optimize your workload, whether you're putting one layer in one device, or and shuffling them around to sort of make sure and minimize that there's not a lot of idle time from the other tiles or the other IPU devices. But that's more of on the advanced side of things. And yeah, so that's the quick sort of walkthrough and talk around how we in Graphcore accelerate NLP pipelines using IPUs in the cloud. And yep, thank you very much.
This was the last session of the NLP Summit 2022. Thank you all for joining this 3-day global community event and for contributing with great questions and with your own experience. In the last 3 days, we have heard in more than 50 technical sessions about state-of-the-art open source NLP, how NLP is applied in healthcare, life science, finance, legal, retail, and other industries. There are many great techniques, tools, and models being implemented today, and we are very excited about everything that is yet to come. If you'd like to watch any of the sessions again, or watch those that you have missed today, you can come back here and watch all the content on demand for the next 2 weeks. All the content will be available here on the platform in the next few hours. For all those who would like to dive deeper into applied NLP, we'll be back next week with 4 days of live virtual training and certification for Spark NLP. The workshops will walk you through state-of-the-art NLP through Johnson Labs, open source libraries, and healthcare-specific libraries. Check out the link in the chat to find the details and register. Thank you again to all of our fantastic speakers and to all of you for being part of the largest applied NLP event and community worldwide. Please keep in touch on Slack, LinkedIn, email, and have a wonderful rest of your week.